Hey everyone, today we're going to be building something a little bit different, a little bit relaxed. We're going to be building Conway's Game of Life with React, and here you can see a little bit of a demo of what we're going to build. We can skip through the states of the Game of Life, we can hit play, and if you're not familiar with Conway's Game of Life, it's essentially a cellular automaton which is Turing complete. There is computers built out of these patterns, and it has a couple of really simple rules that we're going to implement that you can create essentially infinitely living things within the game. And yeah, really cool. Lots of stuff to learn when building out the Game of Life. So that's what we're going to be doing. I will drop a link to a couple of really useful videos that go into the history and some more information about the game itself. But yeah, let's get started and think about how we're going to build this. So you've got two states within the Game of Life. We have alive and we have dead. And that's represented by the white cells that you saw in the demo. They were alive, and everything else, it was dead. Now, the way it works is based on the neighboring cells. So if we have a grid like this, we've got our cell in the middle. Now, these cells around here are the neighboring cells. And you calculate this for both alive and dead cells. So the rules are, if a cell is already alive, if it has 2 or 3 neighbors, so 2 or 3 neighbors that are also alive, then it stays alive. Otherwise, it goes to dead. So it must have 2 or 3 neighbors that are alive, otherwise it goes to dead. Now, if a cell is dead, and we look at it, it must have 3 alive neighbors, and then it will come alive. And that is the rules of the game. There is no more to it than that. So if you've got less than 2 or 3, you die of underpopulation. If you've got 4 alive neighbors, 3, 4, then you would die of overpopulation if you're alive. And when you're dead, when the cell is dead, it must have exactly 3 neighbors. Doesn't matter where they are, but then this cell would come alive. And the game, it works on ticks, let's call it. So let me reset this. So you have a board. Oh, we have a board. And what we're going to do, we're going to go through all of the cells and we're going to compute the next state of the board, the next board, let's say. And essentially, we're going to have a timer, maybe 100 milliseconds, and we repeat this process constantly. So we go from board, we compute the next board, we compute the next board, we compute the next board, always based on the state of the current board. So quite a simple game, and like I said, there's lots to be learned from the implementation of this. So let's dive into some code and get started. So I'm at my terminal. I am going to go into my dev area and let's create a new React project. So I'm going to do pm create next app latest, and let's call it Game of Life YouTube. So we're going to use TypeScript, ESLint, Tailwind, Source, no, app.es, import alias, no. And we're not really going to use any Next.js specific features here. We're just going to use client at the top of the page and then use React. So let's head into here. It doesn't look like everything is installing properly. So let's just update everything. So I do next to latest, rect latest, rect dom latest, and then it looks like post CSS is not happy. So we do tailwind, let's upgrade this as well, do post CSS, and alt prefixer, you can see the tailwind dependency. So I'm just going to upgrade all of the packages. Hopefully we get rid of those peer issues. Awesome. So let's open this up in VS Code and we can get started with our project. So this home page, let's get rid of that. Let's throw on a div with a heading, game of life. And then let's see if this is all working. So let me open up a terminal. Shortcut isn't working for some reason. And then let's run pm dev localhost 3000. And we should see our starter app. So game of life. So let's just add some styles. So let's make this a bit bigger. 3XL, let's put it in the center. Let's make it mono, do a nice themed. And we can also add a bit of padding on the top. Nice. So now that we have our base application, we want to figure out some of the stuff that we need to do. So as I mentioned, we're just going to be using React. So I'm just going to hit use client. And let's think about what we want to do here. So the first thing we want to do is create a board. We want to store the board in state somehow. Store the board in state. We're going to need a function to render out the board. And we're going to be using the canvas element to do that. So we're going to render the board. We need to update the board. We need to create the game ticker. What else do we need to do? Yeah, create the game controls. So I think the rules will be built into our computing of the board. So let's say render the board, and let's compute the board. Cool. Compute the next board. So these are the sort of things that we're going to be doing. I'm going to try to take it quite slow and explain things kind of clearly as I'm going. But let's get started with just creating our canvas and creating a board. So if I make a function create board, it doesn't need to take in anything. And we probably want to type for the board. So type board is going to be, so yeah, number, I would write it like this usually. It's an array of arrays with numbers ultimately. And what you will see is that we have we've got a big array which has got nested arrays like this. And then these nested arrays can have their alive states, so to speak. So simple as this. And then how many of these we have will depend on really the size of the canvas. So create board, that's going to return a board. So what do we want to do? So we want to return an array. And I think the length of the array, we want to calculate that. So let's create some global variables, let's say. So the width of our canvas, let's say, is 800. And the height of our canvas is also going to be 800. We're going to do a square. And yeah, so the cell let's call it the grid size. I want it to be 10. And we can calculate the number of rows, height by grid size exactly, and then number of columns, which is the, that's the wrong way around, guy. Number of rows, width over grid size, and height over grid size. Don't listen to Copilot blindly. So when we go into our array from now, we can say length is number of rows. Like so. And then, yeah, we want to do the same with our number of columns. And yeah, we can fill it with zeros. So let's have a look at what we get. So we say board equals create board, and then it's console log our board. And it's also console.log the length, board.length. So let's open back up our browser. We don't need this now. And let's have a look. So if we go into the console, we can see we've got an array of 80, which is expected because we have here 800 and our grid size is 10. You can adjust these numbers and it should work just fine. So yeah, we can see an array with 80 arrays inside of it, and I don't know if we'll see all of that. Kind of. It's just populated with zeros right now. So okay, not bad, not bad. So we've created our board. So let's create our board state. So we can say board and then set board. Let me call it board state. And set board state is going to be equal to use state. And we're going to give that a board. So let me check this above that declaration. Use state. We're going to give that the board. We need to import use state, of course, like so. And then this is going to be of type board as well. So we have our board and we've got the board in state. And we should be able to see the same thing if we console log out the board state. Give that a refresh. We can see board state. We have got the same thing, but this is now in React state. Now there's one thing to note when we are using arrays and nested arrays. React state, when we call set the board state, React state needs essentially a new array. And that's why we've done this kind of weird syntax where we're doing an array from and then another array from. So every time we're calling create board, we're actually creating both new outer arrays and then all of our rows are new arrays as well. But that's something to be mindful of, that when you have nested arrays, the behavior is a little bit strange sometimes. And there's a couple of things we need to do to make it work. I do actually think this is easier in vanilla JavaScript, to be honest, rather than React. Just from a complexity point of view, you have to worry about a few things when you're using React that you don't have to worry about with just vanilla JS. But hey, we're doing it in React, we're teaching React, so let's do it in React. Okay, so we are going to create our canvas now. So underneath here, let's just create a canvas, and we're not going to put anything inside of it right now. One thing I will do is say the width is width and the height equals height. And if I just put on here, actually let's leave that, that's fine. So width is that, height is that. And we should have a canvas already. It's probably over here somewhere. Yep, you can see it. So 800 by 800 canvas. Let's put on some classes. So let's just do BG gray 900 so we can see it. And let's actually wrap this in a div like so. And then we can make this flex and justify it center. Nope, that's not center. Don't blindly accept stuff. And there we go. And maybe we want to put a bit of a gap on top there as well. Awesome. So we now have our canvas, but what we really need within our canvas is for all of the squares to be rendered. So essentially what we have now is a canvas that is part of our HTML. It's unchanging. And what we want to do when the canvas is rendered on the page, we want to grab it and render all of our grid over it, let's say, of cells. So the way we're going to do that is we're going to say canvas ref equals use ref. Let's import that from React. And it's going to be either null or the HTML canvas element. So we create it null, and then we will say here ref equals canvas ref. So now that we have our ref, we're going to get into some of the Reacty stuff. So we're going to need to, let's get rid of this. So we're going to need to create a use effect. And what we're going to do with this is say when we have our ref, so if ref.current, then this is where we're going to do some stuff, right? So let's think about what we're going to do. So we want to get the context of the canvas. So I'm going to say ctx equals, yeah, Copilot, pretty clever, ref.current.getContext, and we want 2D, like so. What doesn't it like here? Okay, this for sure. So we don't want that. Use effect. And use another one of those. So I like it now. So what's it saying? Ref can be undefined. Cannot find name ref. Sorry, this is canvas ref. So if we've got the canvas ref, then we're going to get the context. And then from here, what do we want to do? So we want to create a filled square. But first of all, yeah, we want to just clear anything off, because this is going to be done. We're going to give it a dependency of our baud state, right? So this is going to be the state updates, and this use effect is going to rerun. So I just want to make sure I don't forget to reset the rect, because the canvas that we're almost painting is not declaratively tied to our state, right? So we just need to clear it out, and then we can do that. And then one thing that I'm going to do is I'm just going to create okay, let me hold off on that. Let me go step by step. So we want to do fill style is fine to be white at the moment, and we can't use optional when we're signing. So I'm just going to say if not context return, and then that will keep TypeScript happy. So the fill style is white, and then this is where we need to paint our white squares. And we're not actually going to have any white squares, right? So we've got this, and then I don't want to do for each. Let's do, so we want to do for. So we're going to take I equals 0. I is less than number of rows. Correct. Let me turn off Copilot. It's kind of annoying. So I is less than num rows, and we're going to do plus plus I. And then we also want to do inside of here for let's do, and let me do row, make this a bit clearer. Row, so we're looping over all of our rows, and then we're going to also loop over our columns. And then for each one of these, we want to fill our rectangle. So we're going to call context fill rect, like so. And this takes in 4 things. So we've got an X, Y, and then a width and a height. So the width and the height, I think, is easy, right? Because we have our, yeah, and I prefer cell size actually. I went with grid size, but cell size. So the width and the height is easy. That is just the cell size. And the X and the Y location, we want to be calculating, so where we are in the loop, we want to be calculating the left-hand side, right? And this is in pixels, right? This isn't in the index. So if we want to do the first square, then we need a 0. So I think what we need to do is we need to divide the width by the number of rows for the x1, and we're going to do a math flaw on that. So we do math flaw, so we're going to take the width divided by the num rows, like so, and then we need to multiply that by the row. And that's our first argument. So y is almost the same. So we do math flaw, we do the height. I'm sorry, this needs to be inside of there. We can do the height divided by the number of columns and multiply that by the current index. And then we need width and height, which is just going to be cell size. And we need another one of those. And yeah, so at the moment we're going to be just doing it white. But remember, the game, it has 2 states. So it can be either on or off, let's say. So let's do this. Let's create, and I'm going to this might be a little bit confusing, but I'm just going to put an array in here. And I'm just going to say white or black. Because what I can then just do, we're iterating over the rows and the calls, and what we're able to do at this point is, so let's pull this into here. So what we're able to do at this point is say fill, sorry, let's just do it directly on the context. Context.fillStyle equals, and then we can say colors and we can index into the colors based on whether we're a 0 or a 1. So we're going to say here, board state, row, and column, like so. And it just realizes I'm typing that this is the wrong way around. So the first 0 is going to be dead, and it's going to be black, and second is going to be white. And that should be good. So hopefully this is making sense. So we are resetting our canvas. Like I said, it's not important right now, but when we start re-rendering, it is important. So we're clearing the rectangle, we're looping through our whole board state, and then we are getting the fill style, which is just going to be a color, and we're each of these locations. So if we index into board state, this is a last row 0, we return a 0. So it's going to index into the colors array. The 0 location is going to be black. And then we're filling the rectangle like so. Hopefully that makes sense. I was thinking this is a little bit strange that we're using, and this needs to be num calls. They're the same at the moment, but it may not always be the same. Yeah, it's a little bit weird that we're not using the board state length for this, but that's based on the number of rows and number of calls, so it's also fine. So let's have a look. So we have everything white, which is going to say not expected. Now we have everything black. So if I refresh this, we'll probably see the render, right? So the HTML canvas has that gray background, and then once it renders, we are looping over and replacing it with black. And if I have a full array of everything alive, what we'll see is it goes everything white. So that's working as expected. So that's good. We are getting there. The thing I want to do on here is, in the original example, we had some grid lines. So I'm going to just put some grid lines. So we don't need to do this inside the loop because it's just going to be the same. So I'm just going to set a stroke style equal to gray. And then let me set the line width equal to, this needs to be a number, something really small, like so. And then we essentially want to repeat this, but instead of fill rect, we want to stroke the rect. So stroke rect like so, and we should get a thingy-mabob, some stroke lines. So why isn't that working? Stroke style gray, line width, fill rect, stroke rect, and the logic is the same. But the stroke num rows, num calls, cell size. That should be correct. Fill rect, stroke rect. This does need the board state in here. It's not going to fix our problem. Why aren't we seeing that? Is it too small? I don't think it's too small. Okay. That's weird. 0.1, 0.01. Was it too small? yeah, appears it is just too small at 0.01. Fine, so that makes sense. So you can see we've got grid lines really, really thin, and what I should be able to do is just increase this cell size, let's say 20, and yeah, we get a much bigger grid. So the next thing I want to be able to do is probably to be able to make these alive, right? So make cells come alive. So when we click on our canvas, we want to track the location that we click, and we want to turn that cell basically alive. And we could have a switch so we can go alive or dead. So maybe a toggle is better. But yeah, that's what we need to do next. So let's implement that. So we do onClick. I'm going to take a function in here, and let's just grab our X and Y. So we need to bring in the event, and we can say X is going to be, so X is equal to event, and we want the native event offset X, and then we want the same thing for Y, just the offset Y, and then let's have a look at what we're getting. So let's pull this up. So when we click now, you can see we're getting, so if we click in this one, we're getting, and this is pixels, right? This isn't cells. So we're getting 15s, and over here we should be getting almost 800. Nice. And if we click off the canvas, it is not doing anything. So to make this, get the index, we want to do, again, math floor, and we take that and we divide it by the number of rows. And for this one, we say math floor, and we take that and we divide it by the number of calls, like so. So when we click in this one, we should get 0, 0. Nice. This one in theory should be 80, 80. 19, 19. Is it because we made it bigger? Yeah. Yeah, that's fine. So in theory, this is now really easy because we have our baud state. So we should be able to say, and this isn't going to work, but if we do set baud state in here, we would take the baud state, and then you want to do, sorry, so let me just do updated baud state equals baud state. And then we want to amend this. So let's say updated baud state, and then we create a copy of our baud state. And we're going to say updated baud state. So the row, so we've got X here, and then we've got Y. We're going to set that to, we're going to set that to 1. So we're going to make it alive. And we're going to set updated baud state in here. So let's refresh, and we can see it's not really working as expected. So num rows, width, cell size, num rows, num calls. 800. So let me just put this back to 10 to make the maths easier. So what are we getting? So where are we console logging that board state? Use effect, board state. Where are we console logging here? So let's get rid of that, because I just want to see. So 0, 0, 3, 3. Something is not right here. So we do math floor divided by the number of rows. So in this example, we're going to get pixels, so let's say 10. Yeah, okay, this is not right. So I think we need to include the width in this somehow. So the offset, yeah, so the offset divided by the width divided by numerals. Offset divided by the height divided by numerals. Okay, yeah, and we're just getting zeros. So if we selected the 80th pixel, we want to 80 divided by, so that would be, we want to get 8. So it's divided by the cell size, right? There we go. Sorry, I'm getting confused. And cool. So what we could do here is say const new. Yeah, so we say if updated board state x, y equals to 0, then we're gonna make it 1, else we will make it 0, and that will make it toggle, so we can swap them like so. Cool. So we've kind of got the fundamentals of what we need done here. So we have our board, we have it in state, we have got a way to make cells alive. We can actually, well, we're updating the board by setting our board state, but now we need to compute our next board. And this is where the logic gets really fun. So we need a way to trigger a compute. So let's create another div here and put in a button, and we'll say next. And then on this button, we are just going to call compute next board, like so. We don't have that function yet, but that's what we're going to create. So let's do under our use effect. Let's put all of our functions in here. So let's do function compute next board. And we don't need to take anything in because we have access to our board state. So let's just console log computing next board. And okay, not expected. So we've got this div. Okay, this one is flexed. Justify center. So let's make this a flex call and do items center. Nice. And then let's just put a bit of let's do that, and we can get rid of that. Nice. So we'll compute in the next board. We're not actually doing anything yet. Fine. Compute next board. Nice. So this function is not going to return anything. We're just going to be updating the board state. So let's think about what we want to do in here. So we need to loop over everything. So if I take this, so we need to loop over everything. And then what do we want to figure out? What we need to know is how many alive neighbors this cell has. So you can do here, so we can have a look at, so board state, and we've got, row and column here. So if we just hit next, we see, okay, we got 6,400 zeros. But what we need to know, if I put a 1 in there, we should see, yeah, we get a lot of zeros, then a 1, and then a 0. So we're accessing the board state correctly. But what we need to do is to count the neighbors. So if you remember where we have like this, we don't care about the middle one. This is the one that we care about, right? So how do we do that? And it's more loops. So let me create a new function. Let's create a function count, let me just call it neighbors like this. Function count neighbors. And then this is going to take in a row, which is a number, and a column, which isn't a number. And yeah, so what we want to do now is take the, I've just deleted that diagram. Let me draw it on the tablet. I think this is probably the most confusing part. So we have, that is a really bad line. So we have our grid like so, and we have this cell. So this is going to be referenced by a row, like here. We've got the row, and then we've got the call, and that's in our board state, right? And we need to count these. So if we take the row number as, let's say we're on row 3, column 3. So if we want to get this value here, how do we do that? Well, that is row 3, but the column is 2. Or if we think of it as 3 minus 1. This one here is still row 3, but it's 3 plus 1. Then this one we don't care about, right? Because it's not a neighbor. Similarly, the one above here, we're now in row 3 minus 1, and the column is also 3 minus 1. This one above, the row is 3 minus 1, but the column is still 3. So hopefully that helps to visualize what we're trying to do. And the way we're going to do that is we're going to say for let r equals minus 1. We're going to say r is less than or equal to 1. And then we say plus plus r. And what this is doing, oh, I'm on the wrong screen. I was just about to flick back. Let me show the code real quick. Oh, not that one. So yeah, I'm doing a loop. So we're calling this function once with the index for the row and the column. And then we're going to create a for loop, which is going to do the row from -1 to 1. And if you think that is going to, it's going to -1. If we do r minus 1, it's starting us here, right? And then this is r, and then this is r plus 1. And that's what that loop is doing. So it's only ever looping over 3 things, because it's between -1 and then less than or equal to 1. And then we're also going to loop over the column. So we're going to be doing a loop between row. Why does this keep resetting? Row -1 to row plus 1. So that's going to give us the r minus 1, the r, and then r plus 1. But then for each of those, so r minus 1, we're going to get another loop. So we're going to do the column -1, the column, and the column plus 1. And that's going to allow us to go through it's 9 iterations, and it will hit these ones like this. And that's not actually the order it will go in, but hopefully you see the point. So let's switch back to VS Code, and let's copy this. We want to, and I'm going to call this dr because it's the row delta. And then let's switch this to, I didn't mean to do that. Let's switch this to CR because it's the column, not CR. Let's call it delta for the column. And then this is going to be 0th, like this. So what do we want to do? What do we want to do in here? So the first thing I want to check is that if, so the delta row is not equal to 0, and the delta column is not equal to 0, because what that is gonna do is when we're 0 on the delta, we're in the middle, right? Because we're going from -1 to 1. So this loop is gonna go row -1, column -1, and then it's gonna do something. The next iteration is gonna be column 0, which is fine because we're then on the left hand side, right? Column 0, column 1. Then it's gonna go row 0, column -1, but then row 0, column 0 when we're in the middle on the 5th iteration. Hopefully you can visualize that. We don't want to count anything there. So we're trying to count the neighbors. So let's make a variable count set to 0. So if we're not in the middle, then we'll say if, and then we're going to say board state. We want to take the row delta, the column delta. So if that is equal to 1, we want to do ++ count. So that means the neighbor that we were at is alive. Hopefully that makes sense. So in here, we want to say alive count equals, what do we call that? Count neighbors. Count neighbors. We want to pass in the row, we want to pass in the column. And then let's get rid of that. And then let's console log the alive count. And let's see what happens. Quite a bit of logic in there, quite a few things to go wrong. So let me put in a few that will have quite a few neighbors. So I'm expecting to see this one has 1, 2, 3, 4. So I'm expecting to see a number 4 in here somewhere. And the other bit of logic that we need to check is that we're not outside the board. So what is happening right now is we are indexing outside. So on the first iteration, if you can imagine, we take index 0, 0, and we get index -1 is the first thing that we try, and so we do the delta row -1, 0, -1. We try index into our board at -1. So we need to do another thing. I'm just trying to think the best way to do this. So yeah, so I can say if DC is less than 0 or DR is less than 0, we just want to continue, I guess. We don't want to do that. Maybe that works. In fact, let's do another piece of logic, which was in the original, and it took me a minute to figure this out. So what we're going to try and do is, actually, if we're indexing here, then, so we still don't want to index, outside of the array. But what we want to do is allow for it to wrap around. So if we're looking at this square here, we can actually look at this location here. And the logic to do this, so I'm going to say the row is equal to, so the row 0 plus the delta of the row plus the number of rows. I'm going to do that, but we're going to mod the number of rows like so. And this is going to wrap, and we're able to do this with the columns as well, numcols and numcols, and then we want to do the row and the column in here. So let's give that a refresh and give it a go. So we can't read undefined 64. RC1. -1, greater than or equal to 1, implement the rows. Column delta is -1, less than or equal to 1, implement the columns. So we don't do it for zeros. This need to be or. I think it needs to, they both need to be 0. So we're taking the row number, add in the delta, and we add the number of rows. Oh, I put the wrong thing. My bad. So let's refresh, try again. So what are we getting back as undefined, because we need to return this count. So hopefully we should see a lot of zeros, and then let's give something a neighbor. Yeah, nice. So we got a few neighbors in there. Awesome. So we're making progress. I know this is a little confusing. It confused me for a bit as well, but hopefully you can follow the logic so that it makes sense. We're essentially wrapping the board around from here to here, let's say. Cool. So now that we have a function to compute the next board, what we really want to do is have it to update the state when we hit next. So the way we're going to do that might be a little bit funky, but it's a way that works. So what I'm going to do is I'm going to wrap set board state around this, and we're going to put the logic in the callback. So set board state, we can pull off the current state, so previous board state, and then we're just going to wrap this inside of here. And like I said, there's a bit of a weird thing with React state and nested arrays. So what I'm going to do is I'm just going to map through the previous board, and we're going to take the row, and then we're just going to merge in that row like so. Previous board state. So that takes a row, and we're essentially filling up a a brand new bod with new arrays. And we can't just do this, or sorry, it would be this, because that is creating a copy of the outer array. But what we need to do is create a copy of the outer array and all of the rows within it. So yes, hopefully that makes sense. So we have our alive count. So all we need to do now is implement the logic to update the new bod. So I'm gonna say, so if previous bod state, and then we're gonna take, we've got row and column, if that equals to 0, then we're going to say if alive count equals 3, then we're going to do new bod, row and column equals 1. So if it was previously dead, but it now has 3 neighbors, we're going to make it 1. Yeah, so else, so if it's not dead, then it must be alive. So then we're going to say if the alive count else, what are we doing? So it must be alive at this point. So then we're going to say, we can just do a ternary for this. So we say new board, row and column equals alive. Sorry, equals alive. So what am I doing? So if we've got the alive count of 2 or 3, so else, so let me just do it like this first. If alive count equals 2, or alive count equals 3, then we want to do new bod, the row and the column equals 1, else new bod, row, column equals 0. Nice. And from this, we need to return the new bod, like so. So if this is correct, so if alive is 2 or alive is 3, then it's 1. Otherwise, it's 0. And we return the new bod. If we're 0, so we're dead, alive count is 3, then we make it 1. And then it's already 0 in here, so we don't need to do a 0 count. And I guess in here we could simplify it and say if the alive count is not equal to 2 or 3, we make it dead because it's already alive. So let's test it out. So we should, if it's working correctly, we should be able to now so it's computing. Compute next bod, set bod state, return the new bod. You see it's going through the logic. However, we're not updating our state. So if the row column is dead, if the alive count is 3, then we make it 1. That is fine. So else it must be alive. So if the alive count, let's simplify this a little bit. So if the alive count is not equal to 2, or alive count is not equal to 3, then it can make that and, then it goes 0. Otherwise it's already alive and we're happy. So that's inside the loop. We come out of the loop and we return a new bod. So that should be good. Bod next, compute next bod. Count and neighbors. And let me just look at this. New bod. So new bod, we should be all dead. Because none of them have enough neighbors. So we are, but it doesn't feel like we are re-rendering correctly. So we do have bod state in here. Set bod state. So set bod state, we got the previous state. I should just take the new bod. Do we need to return something or not? Set bod state. So this doesn't return anything. Previous bod state void. Type void. So yeah, it's expecting a bod. So that's expected. Oh. New bod. Yeah, this is out of bounds now. Yeah, it shouldn't matter whether we're doing previous bod state here or the new bod. It doesn't really matter. It's the same at this point, ultimately. Maybe it's because that's a constant. Shouldn't have stopped me doing it though, right? New bod, previous bod state about. We're getting the new bod correctly. There's something going on with this set bod state. I see the problem. I need to be assigning this, not checking equality. Okay, let's give it a go. So on that one, we can toggle it off. Nice. So it looks like we have got a working, oh, no we don't. I was about to say a working game of life, but this little pattern should fly across our board nicely. So it feels like there is something wrong in our logic. Okay. So counter neighbors. Let's have a quick look through this. So count is 0. We set that when we call the function. We get the delta -1, 2, 1, add it, column delta -1, 2, 1, and add it. So if the delta is, yes, this needs to be or. So if the delta row is not 0 or the delta column is not 0, because yeah, what this is doing is, if I go back to here, it's basically saying where the delta row and the delta column are not equal to 0. So we're essentially missing out on this, 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 and this. Because in all of those places, either the delta row or the column could be 0. Obviously this row, this one here, the row is 0. So we only care if either the row or the column is not 0, because that means they're both 0 and then we're in the center. Alright, so sorry, I kept my iPad on for a minute by mistake there. So that's updated now, and we are working as expected. So this is really cool. You can create all types of structures, basically. Hit next and see what happens. You'll get some really interesting patterns. And like I say, I will drop some things in the description so you can have a read into some of the cool possibilities with this. And just an example there of it wrapping around the other side. Now it's not ideal for us to have to keep clicking next. So we want to implement a play button. Now this is a little bit weird within React, and I don't have a whole lot of experience with like set interval in React or set timeouts. So we're gonna work along this one and see how we get on, see what we can implement here. So I'm thinking I'm going to need a play is playing and to set is playing. And what I'm going to do, I'm going to create a use effect, another one, and this is going to depend on is playing. Now, in an ideal world, what I should be able to do and just say if is playing, then I want to set interval, and let's say we compute next baud every 1,000 milliseconds. I mean, it's more like 100 that we want. And then we can create down here just another button, and we can say play, and then on click, all we want to do is set is playing to the opposite of is playing. And then on here, what we can do is we can say if is playing, then this is going to be stop, otherwise play. So we've got a we've got a play stop button, essentially. Now, I don't think that's going to work. No. And it's to do with the closures of set interval. So compute next board as a dependency. I don't think that's going to make a difference, honestly. Let's see. So it's kind of working. It's continuously doing it, but something is off with the timing. And I think, yeah, I mean, that is not actually stopping. We probably need in here to clear the interval. But I think I need a ref to the interval. Set is interval react hook. No, react hooks. Yeah, react hooks. Set interval and React components using hooks. Let's have a look what we can do. Interval, set interval, and then, okay, so we can take the interval like this, and then clear interval as a cleanup. So that needs to be a function. So we return this function. So if is playing. Okay, so let's do it this way. So if not playing, then let's just return. Otherwise, we do this. Awesome. That looks much better. Stop works, reset. So it looks like we're working. To be honest, I wasn't expecting that to work quite as smoothly. Hey ho, nice, not complaining. And yeah, that is essentially how to code the game of life with React. Now, you can experiment with this as much as you want. And I think it'd be interesting to consider how we expand this. And actually, one thing I want to check is, does this sort of thing work? So, okay, can I just make it bigger? Have we got that working correctly, dynamically? Okay, nice. So that is working. Let's try with some dodgy maths. Yes, so we probably need to do this, right? Because it could be a weird number. Okay, cool. So that's good. You can see we've got bigger and bigger squares. And that's because we made it dynamic with the number of rows and the number of columns. So that's good, that's working. We can change the colors if we wanted to as well. Maybe you wanted not that, black. Maybe you want this one to be, I don't know, green instead. Red. Awesome. And that's working as expected. So there is plenty of opportunity to expand this. So one way to expand this would be to create a different compute board function. So this is a use callback thing now. It's on use callback, yeah. We don't need to particularly worry about that right now. So yeah, there is a different variation called seeds, which creates some other really interesting patterns. So what we could do, so it should work in the same way. So if I call this compute next board game of life, then that will work. That will work, and we should have another error. Yep. So then let's call that game of life. And then what I can do is let's compute next board. So let's just, let's take this whole function and let's call it seeds. And then what we can do, so in seeds, the logic is a bit simpler. So each cell has 8 neighbors, as in life. Each time step, a cell turns on or respawn if it was off or dead, or had exactly 2 neighbors that were on. All other cells turn off. So if it's dead, the life count is 2, it goes on. Else, so if it was dead and the alive neighbors is 2, then it goes on. Else new board R C equals 0. And then we can swap out our functions, call it seeds. And then in here, let's call it seeds. And we should be able to create totally different. Yeah, and you get, this is kind of what happens with seeds. So let's see if we can make this back to 10. And let's see. So let's add a few things in here and let's see what happens. And yeah, this is kind of what is meant to happen with seeds, is it will expand and then you get this kind of like just fuzzy. It's like the old TV. I really don't like that being red though. And yeah, that is a different kind of implementation. And yeah, there is lots of implementations of this, and it might be cool to expand on it. One of the things that we're doing at the moment is we are monitoring 2 states, alive and dead. You can have as many states as you like ultimately and make this as complex as you like. Another really interesting thing to implement would be the smooth game of life, which is similar to game of life, but rather than being alive or dead, you're on a scale between 0 and 1, and you're looking at, instead of looking at just the surrounding cells, so the neighbors, you're taking a much bigger area. And yeah, there's a lot of interesting implementations of this, which are kind of equally as challenging to implement. But hopefully this was a good example and useful. I think it's good to do something that is not just building a website, doing authentication, interacting with a database, that type of thing. It's good to do something a little bit more fun and a little bit more interesting. So yeah, I hope you enjoyed. I will see you in the next one.